Okay, so today we're going to talk about the first quadratic application, which is called projectiles. Okay, so this is the most common quadratic application. There's a couple others we're going to do. What is a projectile? It's any object. Usually we're going to talk about like rockets or balls or anything that can be, projected through the air. Okay, so any object that is thrown with by some force. Okay, so rockets have an engine, balls, you throw or you hit. Basically, that's kind of the scientific definition. It's anything that goes up and then comes back down over some span of time. Okay. And something that goes up and then comes back down. It's modeled by a parabola. If you think about an upside down parabola, those go up and then they come back down. So we model these with quadratic equations. So your typical variables, remember you have your independent variable, usually x. In this case, we're going to talk about x is going to be defined as time. Okay. So usually you see t for time or s for seconds, h for hours, something like that. So it's not going to be x, it's usually going to be t. Dependent variable, what does it depend on? Well, it's for the dependent variable, instead of y, we're usually going to say it represents height or h, or distance for d. Okay. So, again, the variables are always interchangeable. So usually we do x and y. Now we're typically going to use h and t, height versus time. So that means instead of writing things as f of x, f with respect to x, it's going to be h of t. Okay. So you just think of it as the same thing. H of t is f of x, h is y, t is x, same thing. Now we have to be able to discern between the different types of questions we're going to be asked. So if it's asking for the maximum height, okay, the maximum amount of parabola is the vertex. The maximum height would be the y value of the vertex. Okay, that's a what question. The next one's a when. When does it reach the maximum height? Well, the when is time. It's going to be the x value of the vertex, the independent variable. So the max height questions are always think vertex. A when is the x value. A what is the y value. When does it hit the ground? Well, we got another when, so it's going to be x value. And a when does it hit the ground is going to be the x-intercept. Okay? Because if you think about it, the ground, that's when h equals 0, the height equals 0. Okay? So if your height equals 0, or your y value is 0, you're going to have an x-intercept, just by definition. And remember, parabolas usually have two x-intercepts. We're going to be looking at the second x-intercept. Okay? The first x-intercept would be wherever it starts. Well, kind of. How high does it start? Okay, start is a time. It starts at time 0. Okay, when x is 0, that's your y-intercept. Okay. So again, all these pieces correspond to pieces of a graph or pieces of the parabola. Domain. Now, domain's a different one. Domain usually is all real numbers. Okay. For most quadratics, it's all real numbers, but now we're talking about time. So the domain for this is how long it's in the air. Because once it stops being in the air, once it's on the ground, it's not changing. It's not, the model of that equation is done. Okay. So the domain isn't going to be all real numbers. It's going to be how long is it in the air. When does it start? When does it land? The range is the y values. Okay. Now the y values is between the ground, when your height is 0, and the maximum height, which is the y value of the vertex. Okay. So usually we just have, y is less than the highest or bigger than the lowest. Well, now we have the ground. The ground is always going to be the lowest spot. It's always going to be the lowest height. So let's look at this problem. This one's given a graph, but it also gives an equation. So we have the graph on the right. We have h in height, which is feet, and t seconds, which is your x value. And then you're given the equation, h equals negative 16t squared plus 128t. First off, how long is the rocket in the air? That's a time problem. So we're looking at when does it start and when does it land. Okay, now a parabola kind of models the trajectory of a rocket. So it ends at 8 seconds, it hits the ground again in 8 seconds, so it's in the air for 8 seconds. Number 2, what's the greatest height? Okay, greatest height is the y value of the vertex. It's hard to see on a graph, but we do know the x value of that vertex. It's 4. So what we can do is we go to the equation and plug in 4 for t. So negative 16 times 4 squared plus 128 times 4. Just plug that into the calculator and make sure you can get the right answer. In this case, it is 256. So again, that one's kind of hard to see on the graph. but it is 256 when you plug it in. Alright, about how high is the rocket after 1 second? Same thing. We know it's 1 second right there on the x-axis. We know it looks like it's about 100. But we can figure it out for sure by plugging it into the equation. We know t, so we're trying to find h of t. H of 1 is negative 16 times 1 squared plus 128 times 1. Again, plug that into the calculator and make sure you get 112 out. So it is about 100, but more specifically, it is 112. Same thing, 2 seconds. Okay, if you have a time and you need to figure out height, you're going to plug it in. Okay, so this one looks like it's a little under 200. We could figure that out for certain by plugging in 2 into the equation. Plug in 2, and we get 192 feet. Okay, which again, below 200. Is it going up or is it going down? Well, remember, parabolas, they change direction at the vertex. Well, this one's left of the vertex. It's still on that uphill path. So this one's going up. Number 5 after 6 seconds. 6 seconds is right there on the graph. And you could plug in 6, but again, remember, parabolas always reflect. So this is the reflection of the 2-second point, which means it's also 192 feet, which means, you know, we don't have to do any work. You can plug it in and realize you will get the same answer, but since it is the reflection, we don't have to do that. Okay, and this one's on the downhill slide, so it's past the vertex, so it is going downhill. Alright, next page, same graph. Do you think the rocket is traveling faster from 0 to 1 seconds or 3 to 4 seconds? Okay. So we're going to have to find those spots on the graph. Okay. Well, there's between 0 and 1. Change the color back to green here. Keep it organized. Alright, we know between 0 and 1 second it starts at the ground, and after 1 second it's 112 feet. Which means that green line is going 112 feet per second. So now we have to figure it out on the red line, 3 to 4 seconds. 3 to 4 seconds is up towards the top. If you look on the graph, 3 to 4 seconds is roughly between 240 and 260. Okay. So 240 to 260, again, those aren't exact, but that's an estimate. That's 20 feet. 20 feet per second versus 112 feet per second. Okay. Now the other thing to look at there is, you know, these are rates of change. Okay. Height over time. Distance over time. That's a rate of change. So since between 0 and 1 seconds has a higher rate of change, we're going to say it's moving faster. Okay? Just like miles per hour, but this is feet per second. So 0 to 1 seconds because it has a higher rate of change. Now the other way to think about that is look at their slopes. 0 to 1 second has a steeper slope, which means it has a higher rate of change. Okay? Again, all this information from before. We already did number 7, find the exact value after 2 seconds. Plugged it in and got 192. Alright, domain. Now again, domain used to be all real numbers automatically, but now it's not. Now it's how long is it in the air? We already said it was between 0 and 8 seconds. Okay. So as an interval, 2 brackets, 0 and 8, or as an inequality, 0 is less than or equal to, I'm going to change that to t, which is less than or equal to 8. Okay, so again, interval notation, inequality notation. What's the range? Range is the y, so the lowest y value to the maximum y value. We already found the maximum. We know the ground is 0. So 0 to 256 as an interval with brackets. Or, not of, 0 is less than or equal to h, less than or equal to 256. Alright. Intervals of increase. Okay, intervals of increase are the x values of which it's increasing. We already said it starts increasing, hits the vertex, starts decreasing. Okay. We are only talking about x value, so you have to figure out the x value of that vertex, 4 seconds. So the interval is, when does it start increasing at 0? It stops increasing at 4. That's going to be a parenthesis, not a bracket. You could convert that to an inequality if you want. And then it stops increasing, starts decreasing at 4, stops at 8, which is the end of the domain. Alright, now algebraically, this one doesn't have a graph. You can make a graph, but you don't have to. So this one's h feet, t seconds, different equation. What's the height after 3 seconds? Plug in 3. 144 times 3 minus 16 times 3 squared is, again, make sure you get these answers out. and it is 288 feet. Number B, what's the maximum height the ball will reach? Okay, now remember, maximum height is always going to be the vertex. So we have to find the vertex. The question is asking for what, but before we find what, we have to find when. We have to figure out the x value of the vertex. Remember the formula for that. It's the opposite of b over 2a. Now this equation is not in standard form, so you could rewrite it in standard form, or you could just remember a is always going to be in front of the squared value, b is always going to be in front of the linear value. So in this case, a is negative 16 and b is 144. There should be a t up top. Plug that into the formula, and you get 4.5. Okay, this is an x value, it's in seconds. So after 4.5 seconds, that's going to be the x value of the vertex. That's the when. We need the what though, so we need the y value. Okay. Well, if you have the x value, just plug it into the equation. Plug in 4.5 for all the t values and evaluate. Okay. So we plug it in. Again, make sure you get the answer, the correct answer. 4.5 t is t. You get 324 feet. That's the what. Okay. The question asked for the what, so that is our answers. The max height is 324 feet. It happens at 4.5 seconds. Okay. And the last one, when does it hit the ground? Ground is x-intercepts. It's when h is 0. So plug h equals 0 into the equation. So instead of h of t, you got 0 equals 144t minus 16t squared. How do we solve this? Well, you factor. Okay. More specifically on this problem, since it only has two terms, we can do a GCF. The GCF, each value has a t, and 16 does go into 144, so the GCF is 16t, which leaves behind 9 minus t. Now solve. Zero product property. You have two factors, you have 16t, you have 9 minus t. Set each one equal to 0. 16t equals 0, so t equals 0. Okay. But that's not going to be, that's a starting point. T equals 0 is the start, so that's not our answer. So try to answer the other one, solve the other one, you get t equals 9. That's going to be the ending point. Okay. It starts at 0 seconds, it ends at 9 seconds. That's how long the ball is in the air. Okay. Alright, so bring it back up to the top here. And, that's the kind of the gist of projectiles. This is the most common application of quadratics. So it's the most, and this is the one we're going to go in depth with the most. Okay. So just remember, be able to identify what type of problem is being asked, what part of the graph you need for that particular problem, whether it's the vertex, whether it's the intercept, whether it's some other point. And remember, domain and range are also different. Okay, so it's very similar to quadratics, but now since we have an application to it, it's things change a little bit. Okay, so we're gonna do some of these for homework. We're gonna do some different projectile we're gonna do different applications next.